as we look at page 18, my question is, and maybe you could kind of read between the lines, would I ask this question if it was true? Do we think the cosine of x plus y is the same as the cosine of x plus cosine of y?
No.
I know you'd wish that it was, right? And you're like,
it doesn't because
it doesn't.
Because if you do, because I.
We're going to prove this. So you guys, let's to your point, Coop, let's pick an x and a y. You guys, give me an x on that unit circle. And I know we haven't seen that unit circle in a while. On that. So we picked our x and our y. Arbitrary. Could be any radians from my unit circle. And I just plugged in x here, y here, x here, and y here. And we're going to see if they're equal. Pi over 6 plus pi over 4. Can we get some com-doms on that? Because we got to add those up. What would that turn into? Cosine of 2 pi over 12 plus 3 pi over 12 is going to be 5 pi over 12, which again isn't quite on my unit circle. Funny, we will be putting it on our unit circle, won't we, Miss Queen? But let's go see what we get over here. What's the cosine of pi over 6? Ooh, cosine of pi over 6, x or y coordinate? X, so it's root 3 over 2. Good memory, Beck. Root 3 over 2. What's the cosine at pi over 4? Root 2 over 2. And so I'm just going to say that that's root 3 plus root 2 over 2. And we're like, I'm not quite sure. Maybe they are equal. Something that I can do to check it is I can go to my calculator. I'm going to just make sure that I'm in radians. And I'm going to say, what is the cosine of that 5 pi over 12? And is that the same as, you guys don't need to type this in. I'm just kind of trying to prove something for you. Root 3 plus root 2 all over 2. Did we get the same thing? Dang it. We didn't. So you guys, I want you to put a big slash. They are not equal. They are not equal. Our life would be so much easier if they were. But I apologize, guys. They're not. We can't just distribute this out because this is that angle and we can't break that angle apart. So Coop, you knew, no. So what are we going to do instead? They've got something called this sum and difference identity. Woo, look how pretty that is. This is pretty. Look at this. We've never seen one of these signs before. Have you guys seen Plinus?
Yeah.
Yes. Have we seen minus plus?
No.
No. I know, it's kind of a fun new one. So they're saying when you've got two angles, the cosine of two angles, alpha and beta are what they used here. I love drawing a little alpha. It's like this woo little fish, beta woo, like a little bee with a tail. I like them. You have to then say cosine of alpha, cosine of beta, minus plus sine of alpha, sine of beta. What do you think, how would I know which one to use as I look at, say, this first problem that they gave us? Here's what I want us to do. I'm going to get rid of this for right now. At this problem that they gave us, they said cosine of x plus y. Or I want us to kind of go right back here. If this is my alpha and my beta, do you agree we used a plus sign here?
Yeah.
The plus sign's on the top or bottom down here? Top. Whatever you used, if we're on the top here, you stay on the top. Does that make sense? So we'd use the minus over here. If I did cosine of pi over 6 minus pi over 4, I was on the bottom. I'd stay on the bottom and I'd do a plus sign there. That's how that works. Let's go prove it now. Let's go see if we can go really find this value out. So now let's just go prove what we just did. Cosine of pi over 6 plus pi over 4. Let's go find out that that really is that cosine of 5 pi over 12. If I were you, I'd be saying, oh, that's my alpha and that's my beta. I think that is very helpful for us using this formula. I want you to know, Miss Queen nor I will never make you memorize this. You just have to be able to apply this formula. All these formulas, you don't need to memorize them. There's no point. But can we apply? If we're trying to do cosine of alpha plus a beta, what would I write right here? It's going to equal the cosine of, love it, cosine of pi over 6 times the cosine of my beta, pi over 4. We did plus right here, so I was on the top. So now I've got to go on the top over here. Minus sine of pi over 6, because they say minus the sine of my alpha. My alpha was pi over 6. Times sine of, you got it. Let's go back to that unit circle. Unit circle, clap, 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 clap. Here we are. Sine, okay. First they want the cosine of pi over 6. Cosine of pi over 6 is what? Root 3 over 2. Cosine of pi over 4. Beautiful. Root 2 over 2. Minus sine at pi over 6. Sine, very good, is 1/2. Sine at pi over 4. Beautiful. You guys, now we're going to be a little uncomfortable because I want you to do this and simplify. What happens when I multiply across here? I'd get root blank over blank. Root 6 over multiply them. Yes, root 6 over 4 minus root 2 over 4. Do we have common denominators? Sure do. Root 6 minus root 2 over 4 would be my final answer. Question. Is that going to get me the same thing when I type this in? Check this out. I'm going to prove something for you guys. I'm going to do it for you. And I'm going to do it for you. The cosine of pi over 6 plus pi over 4. I got that. And is that the same as root 6 minus root 2? Minus root 2 all over 4.
Yes.
Okay, so can we just distribute it out and say it's equal to cosine of alpha times cosine of... Nope. We got to go through this formula. You guys, use the sum or difference identity. Find the cosine of 735. Here's what my question is. Do we know where 735 is on my unit circle?
No.
No, agreed. Don't. But how could I put that in terms that I would know? How could I make 735 a little bit more manageable?
Like putting it in radians.
He's saying subtract a rotation. Still don't feel great about it. Subtract another rotation, Sean. I dig it. So you're saying cosine at 735, Sean, I love it, is the same as the cosine of 15 degrees. They're co-terminal angles. Awesome. Do you guys agree? 15 degrees is not on my unit circle.
It's pi over 12.
It is pi over 12, but it's not on my unit circle.
Yes.
No, it's not. I don't have pi over 12 up here. My question is, what could I, check this out, look at what this gives us the availability to do, add or subtract on my unit circle in degrees this time in order to get a 15? Are there any degrees that if I added or subtracted them, I could get a 15? It would be negative 15. 45 minus 30 is 15. What if Ryan Livingston Sanders said, I would have done 60 minus 45. Is that still 15? Yeah. What if Mateo in his ordinary self wanted to do 315 minus 300? Is that still 15? Yeah. You guys, you could do any of them. Do I like the most basic? I do, personally. So you can say that's the same as the cosine of any two angles subtracted from each other to get 15. Which ones are we going with, you guys? 45 minus 30. Thanks, Harvey. Okay. What did we just decide, you guys? You just picked my alpha and my beta. Then we just have to apply this formula. Again, we're not going to make you memorize it. Can you apply it? So we're going to say, okay, the cosine of alpha minus beta is what we did here. And maybe I'll put a minus sign right there just to remind myself, like, ooh, I went minus. We're on the bottom. We got to stay on the bottom. So what are we going to have? Cosine of what? 45. Times the cosine of 30. And you guys, I really recommend writing this out. Don't be trying to do all this. Don't be combining steps and already go into the unit circle. It's too much. If I did minus, that's on the bottom. I got to go plus, which is on the bottom. And then I'd have sine of. Beautiful. Now I'd go to my unit circle. What is the cosine of 45? Nice. The x-coordinate at 45 degrees is root 2 over 2. Cosine at 30. Good. The x value there is root 3 over 2. Plus the sine at 45 is root 2 over 2. Good job, Harv. And the sine at 30, sine E, the y-coordinate there is 1/2. Multiply across without your calculator. It's going to look very similar to our last one, I think.
Yeah, it has the exact same answer.
Oh, you be careful there, Mr. Cooper Mead. I see a minus sign there.
Well, yeah.
Oh.
That's the step before that.
Final answer, root what over 4? I'm sorry. Careful. Isn't it 3 times?
Root 6 plus root 2 over 4.
Root 6 over 4. Oh, I see what you're saying. Plus root 2 over 4. Good question. This, buddy, is like an X. This one's a Y because they're not the same root. We cannot combine them. So we would just say straight up root 6 plus root 2 over 4 because that would be like an X plus a Y. Porter, what if I gave you 4 root 6 plus 5 root 6? That would be like 4x plus 5x is 9x or 9 root 6. When the roots match, then you can add them.
Okay.
We okay, peeps? Now, to Blake's point, could I check this if I put this in radians, if I went back to my mode, I said, ooh, I want to go to degrees on this one. The cosine of 735, Blake, gets me this decimal. I never would have known it. And if I were to check what is root 6 plus root 2 and divide that by 4, boom, we know we got it right. Okay, we're going to look at tangent first. Ooh, does this look like the same thing as cosine?
No.
Not at all. Gross. Gross. But am I going to give you the formula? Yeah. They want us to know what is the tangent at 285. You guys, is 285 on my unit circle? 285 is not there. But it'll still have an x-coordinate and a y-coordinate. We just got to go find it. What plus or minus what could get me 285?
Does that mean 15?
But 15 is not on my unit circle.
But we just found out 52.
Oh, gosh. No. We got to use only things on our unit circle. So you're saying 240 plus 45 would get me 285.
Yes.
I agree with that. Give me another one. I want to get 285. 225 plus 60 would get me 285. That's another way we could have done it. A new alpha and a beta. Is there another thing? 330 minus 45. Yeah, that would get me 285. That took me a second. That was good. Could that be my alpha and then 45 be my beta and do a minus? Absolutely. Any other things we're seeing? 135 plus 150 could get me 285. Any of these worked, you guys. Any of those could be our alpha and our beta. Let's just decide on one together. Which one do we want to use for our example? 240 plus 45? Okay. He says, let's go with that one. We okay with that, people? So let's go say, all right, I know the tangent of 285 is the same as the tangent of 240 plus 45. And again, maybe some people are going to throw their 45 in front. I don't care. In the way I wrote it, my alpha would be 240 and my beta would be 45. We got to apply this thing. Look at this guy. Ooh, we went alpha plus beta. So what are we going to start with? That would equal the tangent of 240. Do I do plus or minus if I did plus to start? Plus was on top, so I have to stay on top. Isn't it plus up there? You want me to say that again, Mateo?
Yeah.
Yep. Mateo, you agree that for us to get 285, we said 240 plus 45 is 285. Plus in my original, the plus is on top. We have to stay on top for all of these now. Plus is on top here, minus is on top on the bottom. So when we get to it, we will use a minus. Mateo, thanks for voicing that. Over 1, now in this case, you guys, we stay on top, we use what sign? Minus tan of, good, that alpha was 240, stop touching each other. Tangent of, and you agree that we're multiplying, we are multiplying these two here. Yeah, that's the difference between what we were doing to them up here. Okay, peeps, 240. Tangent of 240. Here's 240. Tangent. What over what? Y over x. Negative over negative is a Root 3 over 2 divided by 1/2. Yeah, the 2's are going to cancel, and I'm just left with a positive root 3. I'm down with that, okay? We got a root 3 there. Plus, ooh, you guys chose good ones. Yeah, tangent at 45. Y over x, anything over itself is just 1. Over, what do I do with this one? Leave it. Minus. Did I already find out what the tangent of 240 is? I did, so that's really convenient. We got our root 3 from before, and we just have to multiply that by our tangent of 45, which we already found out was 1. Let's simplify it. Yeah, he's saying, all right, then on top I'd have root 3 plus 1, and on the bottom I'd have 1 minus root 3. Do you think I'm cool with having a root in the bottom? I wish I was. I'm just not cool. I'm not cool, guys. Anyone remember how we can get rid of conjugate? I can't just do a root 3 because then that would make, if I multiply this by a root 3, it would turn the 1 into a root 3. The conjugate will cancel things out nicely. So you guys, what is the conjugate of that denominator? 1 plus root 3 on the top and bottom. Okay, people, stick with me. We're almost there. Well, that means that we got to FOIL the top and the bottom. Let's do the top. What's root 3 times 1? Good. Be very careful. Root 3 times root 3 is 3, because root 3 times root 3 is really root 9, which is just 3. What about here then? Plus 1 plus root 3. What about the bottom? A conjugate? I do love a conjugate. What am I getting with the first terms? What am I going to get with my first here? Let's just do step by step. 1. What's going to happen with my outers?
It's going to be a difference of squares.
True. 1 times root 3 would get me I'm going to write it for people that might need it. You don't have to write it though, because then what's my inner going to get me? Minus root 3. They cancel. You never have to write them with the conjugate. What would we end with? Minus 3, right? Very good, Ritz. And now, Porter, I'm kind of glad that you asked that question on the earlier problem. Can I combine 1 root 3 plus 1 root 3 to get 2 root 3s? Plus, over, beautiful. Can I simplify that?
Maybe.
Let me back this up. Let's take out roots. Let's back this up. What if I had 12 plus 4 over 2? Is that the same as 16 over 2, which is 8? Is that the same as 12 over 2 plus 4 over 2?
Yeah.
Is that the same as 6 plus 2? Oh, look at what I wrote over here. I didn't write that right, you guys. Right? My bad. Right? So, do these have something in common right here?
2.
Can I take that out? Yeah. What would that turn into? Because what would a positive 2 divided by a negative 2 be? Negative. So how would I write that? Negative root 3. And then minus 2. What if Annabelle wrote negative 2 minus root 3? Same thing. Here we go. Now I want to try this one. Because you know sine's got its own fancy little rule. You know what I'm saying, people? Sine's got its own fancy little rule. Am I going to make you memorize it? No. Do we have a plinus and then a plinus? They didn't switch it up on us. Okay. Check this out. This one's a little diff. It's very similar. But look at what I asked you. Find the value of sine of x minus y. You guys, I just want us to apply. You okay? Okay, you guys, what I want you to know. Do you agree? My alpha in this case is an x and my beta is a y. I want us to go write that. My alpha is an x minus my beta, which was a y. And I want us to go apply this to this. We could do it. We are smart people. I have no numbers that I'm plugging in there. Don't worry about it. My alpha is an x, my beta is a y. What would I write right here? Sine of? Agreed. So let's go write sine of x. I'm actually going to write sine of x minus y equals sine of x Then we have to write times the cosine of beta. In this case,
Cosine of y.
agreed. He says, all right, times the cosine of y. This negative sign does not go with my alpha or my beta. It helps us decide which symbol we use over here. Since we had the minus, which was on the bottom, Mateo, you down with me using the bottom? Minus, which is on the bottom. So I'm going to do minus, then what?
Cosine of x
Agreed?
times sine of y.
Beautiful. Beautiful. This part, Miss Queen, I didn't tell you this. The kids are like, oh my gosh, what is this even referring to? This is just talking about domain. You guys don't let this stress you out. That's just kind of the legal terms, if you will.
Useless.
Now, could I go plug in some stuff? Do we know what the sine of x is?
Yes.
Okay, we know that that's 9/14, so I'm just going to put in a 9/14 right there. Do I know what
That's
the...
941.
Oh, golly. Thank you. It's a Monday. Appreciate you, Coop. Do we know what the cosine of y is? Don't know anything. So you know what I'm going to do? I don't know what's going to go in there, but we're going to figure it out in a second. Do we know what the cosine of x is? Nope. Do we know what the sine of y is?
725.
Yeah, you know it. Oops. 7/25. Okay. This is why this one's a smidge diff. Whew. I want to focus on this sine of x equals 9/41. When we use SOHCAHTOA, that only works in what kind of triangles?
Right.
Right triangle. Could I make a little triangle over here and be like, okay, if that's my x, the sine of x is 9/41. Sine is blank over blank. Opposite over hypotenuse. So what do I need? I need the cosine of x. Over here says I need the cosine of x. Could I find the cosine adjacent over hypotenuse?
Yes.
What would I do to find that adjacent? Pythagorean theorem. This is going to be a triple. You're welcome. I don't even know this one off the top of my head, though. What squared plus what squared would get me 41 squared? 9 squared plus, let's call it b squared, if you will. Go find that b for me. Okay, so we got b is 40. Okay, if my b is 40, oh man, things have fallen off the wagon, people. I don't know. Oh geez, my 941st, they got divorced apparently. Okay, all right. So do we know what the cosine of x would be now?
Yes.
SOHCAHTOA, blank over blank. Yeah, do I put that where the cosine of y is or the cosine of x?
Cosine of that.
Yeah, so just be careful. We got to put that 41st over here. What am I going to do to go find the cosine of y? You're like, dude, you got to go use this info now because that's got a y in it. So I'm going to go create another triangle with an angle of y. And the sine of that triangle, so is opposite over hypotenuse, 7/25. Ooh, this one I do know this Pythagorean triple off the top of my head. 7 blank 25. 7, 24, 25. That's a Pythagorean triple. If you're like, oh, I wouldn't have known that. Yep, we just do it off to the side. 25 squared minus my 7 squared, square root it, and we get 24. Will that allow me to find the cosine of my y? What are we going to do for that? You know it. 24/25. Is that right, Mateo? Okay, that looks nasty. I am going to let you use a calculator. Thank goodness Beck got his out. And let's go multiply those across. 9/41 times 24/25 minus 40/41 times 7/25. We're going to get a nasty number. Oops, I'm in the wrong. Oh, which mode should we be in? Well, how do I know I should be in radians? Because there's pi. We got to be in radians. Not that it should matter. Because we didn't do trig in it. What'd you guys get?
64/10.
Yeah. Negative 64/1025. That's my answer. The last thing, we got to verify this is that. What? This is like what our 7-2 quiz was on. We don't even have a rule for cosecant. But cosecant's the same as
1 over cosine.
1 over sine. So could I rewrite this as 1 over the sine of 3 pi over 2 plus a? And to that, you're going to say, yeah, you can. What's my alpha? What's my beta? Alpha, is my 3 pi over 2. And my, don't be scared, people. I'm going to go bring this equation down because we got to use the sine one. So I'm going to clean it up a smidge. And then I'm going to bring it down just so that we can reference it nicely.
Okay, where's the unit circle?
I know you're going to have to go back to a different packet. But I'm also going to pull it up. Here's our equation. Let's go just work on this left side. We'd have 1 over. Don't forget to keep that 1 alive. Whoo! What are we going to put first if my alpha is 3 pi over 2? Sine of 3 pi over 2. Cosine of a. That's all we can do. Mateo, I did alpha plus beta here. I did alpha plus beta. What do I need to do over here? The plus one, right? Because we stayed on top.
Yeah.
Good job, buddy. Cosine of 3 pi over 2, thanks, Beck, times the sine of a. You guys, we got to get this to simplify to negative secant. Good to know. I'm going to pull up my unit circle for you. Sine at 3 pi over 2.
60.
The sine. Sine down here. Siney.
Oh,
Negative 1, right? So we have 1 over a negative 1. Can I do anything to the cosine of a? Do I know what the cosine of a is? No idea. So I'm just going to leave it as the cosine of a. Plus, what's the cosine at 3 pi over 2?
0.
Ooh, the x-coordinate at that same spot is 0. Very good, Porter. Times the sine of a. I can't do anything with that sine of a. Could we simplify? 0 times anything is going to get me 0. And he's saying, oh, I see that we've got a 1 over a negative cosine. What's 1 over cosine? Secant, and since it's negative, it's going to be a negative secant. Well said, VC. So VC saying, oh, 1 over cosine, that's just secant, so the negative is going to stay out front. Did I get what I started with?
yeah.
Sure did. The last thing I want you to do, we got 9 minutes, which is more than enough time. Let's go do the cosine at 165.
Okay.
I just want you to do this number 5. Here's my answer off to the top right. We're obviously going to be using this equation. You've got to come up with 2 angles in degrees that add or subtract to 165 to pick your own alpha and beta.